In this video, we're going to go over the steps required for providing the inputs for the Describe Road section of the Seed Street Lighting tool, the first step of the inputs required. The first thing to note is we have two columns here for inputs, one for baseline and one for upgrade. You can enter the same values in both situations, in both columns, for instance if you're doing a fixture replacement, but if you do want to analyze different choices, you can enter different values as well. Let's go through the first section, road geometry. This describes this layout of the road itself and the number of lanes that it has. So the first input is, of course, the number of lanes. Here we can enter the value. In this case, let's do 4. The lane width is the width of an individual lane, so the entire road width will be the number of lanes multiplied by lane width. Let's assume that this is 4 meters. The median width would be the median in the center of the road if you have one. Let's assume that we have a 1 meter width of our median. In the next section, we have the inputs for light geometry, which describes where the fixture is located in relation to the road itself. So the first of these is pole placement. There's a couple choices for poles and how they can be configured in the seed tool. The first one is single side, which means that all fixtures are on the same side of the road. Staggered, we have fixtures on both sides of the road, but the side B is located halfway between side A for each of the fixtures. For median mounted, we assume that there are 2 fixtures in the center of the road, back to back, facing into the lanes on either side. And finally, for the opposite configuration, we assume that there's fixtures on both sides of the road and that they're directly across from each other. Let's choose the opposite configuration for this example. The luminaire mounting height is the distance directly straight vertically from the road surface to where the fixture itself is located. This might be slightly different from the pole height if there's any curvature to your arm, mounting arm for the pole, or any other considerations such as the distance of the pole below the road surface. In this case, let's assume that there's a 10-meter mounting height. The pole spacing is the distance between the poles on one side of the road. So for instance, in the staggered configuration, this would be the distance between poles on side A, and the pole on side B would be half of this distance from that on side A. Let's assume that there's a 35-meter pole spacing. The setback is the distance from the edge of the road to the pole itself, and then the arm length is the distance from the pole to where the fixture is located. So the difference between these will tell us how far into the roadway or behind the edge of the road the fixture is located. So let's enter 2.5 meters and 3 meters. And I'm going to assume that the baseline and upgrade roads are using the same exact configuration, so I'll just paste these inputs over. The last thing we need to look at is the pavement surface type. The lighting standards, both the IES and CIE standards, define 4 different types of road surfaces for their standard configurations, varying from concrete to asphalt with different light characteristics. These are defined by R1 through R4. If you need definitions of these, you can follow the question mark here. Let's choose an R3 type. And that covers all the inputs that we need for this step of describing the road. If we want to take a look at what these inputs look like, we can click Update Baseline View. The pop-up box here notes that the IES and CIE standards are the 2 different choices we have for representing the roadway here. This is only because there's slight differences in the assumptions of number of fixtures and the measurement grid that will be used for those 2 different standards, and this will reflect on how we view these values. Let's choose the CIE method. And you can see that the fixture graph has been updated. We have a 4-lane road with a 1 meter median spacing. You can see the location of every measurement grid point where we'll be doing calculations for light levels, and you can see all of the fixtures that will contribute to the light levels that will be covered. We can do the same thing for the upgrade view down below. In this case, it would be the same inputs, but if we choose the IES method instead, There'll be a slight difference in the number of measurement grid points and the number of fixtures. At a later step, we'll choose which of these methods we want to use for the actual calculations, or we can do calculations using both methods. And that's it. Next, we'll move on to setting the lighting targets.